this, right? Now you get a problem. And one of the best ways to solve it is to just reset the machine, right? And many other things as well. You basically get a clean restart, a clean reboot. This is why even today, the go-to kind of troubleshooting still is, for many situations, is basically just turn it on and off again. And it really is true, right? Whether it's a machine, a laptop, simple machine, and so on. So dynamic host configuration protocol, right? The DHCP. So remember, we talked about this with our network that we created, right? We created a little scope. And that scope then gives out IP addresses through DHCP, right? Then we can create another scope here for the access point, right? For Wi-Fi. I showed you my scopes, right, on my router and all this other stuff. So DHCP uses the DORA process, discover, offer, request, acknowledge. This is the protocol of the application layer. It's used to provide subnet mask, router address, DNS address, and vendor class identifier. It provides an automatic IP address to hosts which want to connect to a network. So it uses UDP67 for servers and UDP68 for clients. You can see here this four-parter conversation we saw there we just saw this in Wireshark, right? So at first the computer has no IP address. It discovers DHCP or DHCP discovers it. The DHCP creates an offer. Computer accepts. DHCP acknowledges. Sorted. So the DHCP is also used to provide the subnet mask, router address, DNS address, vendor class identifiers, and so on. In fact, DHCP provides an automatic IP address to hosts which want to connect to a network. So this DORA process is a DHCP cycle, which includes discovery, DHCP offer, DHCP request, and DHCP acknowledgement. This is the cycle through which a client goes before getting an IP address through a DHCP server. So static IP address is assigned manually, and then it's fixed until we change it manually. Right? I showed you the static IP. So if you put a static IP, that address is going to remain until you change it manually. You can also have DHCP reservations, which is kind of similar to static IP, meaning you lease the same IP address based on the client's MAC address or other interface identifier. So the same computer gets the same address, but it's still a lease. Why would you do this? Well, there's some reasons to do this, but it's really more for later if you end up in networking to know. So why bother with these leases? Why would we lease an IP address for some amount of minutes or days? Why not just give, the IP address for like forever, right? Or for, I don't know, 50 years. Now we could set it up to 50 years, but why do this? Why bother with this? Well, there's actually a good reason. Some are security-based reasons, and other reasons are simply the fact that IP addresses could run out. For example, in that center where I used to work, we had 4 big classrooms, we had an exam room, we had like the office, we had the server room, and so on. And we also had Wi-Fi, and then we split the Wi-Fi later into Wi-Fi for us, the workers, employees, and then Wi-Fi for the guests. And this is also a security measure, right? So this Wi-Fi that was for